A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
I was looking at my hand the other day while I was working, and I realized I had been holding my mouse in this cramped position for about 6 hours straight. It is almost a permanent claw shape that my body has accepted as the price of doing business. In the digital age, most of us are still using pointing devices that are refined versions of what came out in the 1980s, which is wild when you think about how much more time we spend on screens now compared to 40 years ago. We are talking about the Xerox Alto and the early Macintosh era designs being the foundation for tools we use for 10 or 12 hours a day. Today's prompt from Daniel is about ergonomic pointing devices for knowledge workers, and it is a topic that hits home because we treat our primary interface tools as an afterthought until our wrists start screaming at us.
Herman Poppleberry here. Daniel is really onto something with this. We talk a lot about the software stack or the hardware specs of our computers, but we rarely discuss the input stack. That is the physical layer where your biological self meets the digital machine. If that interface is poorly designed, you are essentially building up technical debt in your own joints and tendons. Consider this. We upgrade our phones every 2 years and our laptops every 3, but the median age of a professional knowledge worker's primary mouse is often over 3 years old. We are using degrading sensors and mushy switches on a device that is fundamentally misaligned with human anatomy. Daniel mentioned he moved to a vertical mouse a few years ago and never looked back, even using an artificial intelligence tool to analyze his grip. That is the kind of intentionality we should all probably have given the sheer volume of clicks we execute.
When you see someone with a vertical mouse for the first time, it looks like they are holding a shark fin or some kind of strange futuristic joystick. It looks alien. But Daniel's experience of a brief adjustment period, followed by a much better experience, is the standard trajectory for people who make the switch. It is that adjustment valley where people usually give up. Why is the standard mouse, the one we all grew up with, so fundamentally flawed from a physiological perspective? Why did we settle on the flat puck?
We settled on it because it was easy to manufacture and intuitive to slide around a desk. But the biggest issue is forearm pronation. When you put your hand flat on a desk to use a traditional mouse, you are rotating your radius bone over your ulna bone. That twist in your forearm puts constant tension on the muscles and tendons from your elbow down to your fingertips. It also compresses the median nerve in your carpal tunnel because you are applying pressure directly to the underside of your wrist where it meets the desk. If you just let your arm hang naturally at your side and then bring it up to the desk without twisting, your palm would be facing inward toward your body. That handshake position is the neutral posture for the human arm. A vertical mouse acknowledges that reality and tilts the device so your arm stays in that relaxed, untwisted state.
So, the standard mouse is forcing us into a mild, constant state of physical stress just to keep the cursor moving. Let's look at that grip pattern Daniel mentioned. He used an artificial intelligence tool to analyze his hand geometry. For those of us who just grab whatever is on the desk, how do people hold these things? I have heard terms like palm grip and claw grip thrown around in gaming circles, but how does that translate to the average person writing code or managing spreadsheets?
Comfort really comes down to this, and most people do not even know which one they use. The palm grip is the most common, where your entire palm rests on the back of the mouse and your fingers lie flat on the buttons. It is generally the most relaxed because the mouse is doing the work of supporting your hand weight. Then you have the claw grip, where only the very back of your palm and your fingertips touch the mouse. It gives you more precision and faster clicking, which is why gamers love it, but it creates a lot of tension in the arch of the hand. Finally, there is the fingertip grip, where your palm does not touch the mouse at all. You are moving the device entirely with your fingers.
That fingertip grip sounds like a recipe for a repetitive strain injury if you do it for 8 hours. It feels like you are constantly micro-adjusting with tiny muscles.
That happens because you are putting all the mechanical load on the smallest muscles in your hand rather than using your larger forearm or shoulder muscles. The problem is that many people use a claw or fingertip grip without realizing it because their mouse is the wrong size. If you have large hands and you are using a tiny travel mouse, you are forced into a claw grip. If the mouse is too big, you might be overextending your fingers to reach the scroll wheel, which leads to extensor tendinitis. This is where those artificial intelligence analysis tools come in. They usually have you take a photo of your hand next to a standard object like a credit card for scale. They look at the length of your hand from the base of the palm to the tip of the middle finger and the width across your knuckles. Matching those dimensions to the curvature of a device is what prevents you from subconsciously tensing up.
I imagine the angle of the verticality matters too. I have seen some that are just slightly tilted, and others that are almost 90 degrees straight up. Is there a sweet spot, or is it purely down to personal preference?
Research, including studies from the Logitech Ergo Lab, points to an angle between 57 and 70 degrees as the ideal range for reducing muscle activity. The Logitech MX Vertical, which is what Daniel mentioned, sits right at 57 degrees. They found that this specific angle reduces forearm muscle strain by about 10% compared to a traditional mouse. It sounds small, but over the course of a year, that is a massive reduction in cumulative stress. Some specialized boutique brands go even steeper, but then you run into issues with the mouse sliding away from your hand or having to grip it too tightly to keep it stable. You want the mouse to stay put under the weight of your hand without needing to squeeze it.
Let's look at other options, because a vertical mouse is not the only way to escape the traditional slab. Trackpads have become huge, especially with the popularity of MacBooks. I see people using the standalone Magic Trackpad on their desks all the time. From an ergonomic standpoint, is a trackpad better or worse? Because you are back to that flat pronated hand position, right?
True, but the trackpad introduces a different movement. With a mouse, you are often using your wrist as a pivot point, which leads to ulnar deviation, that side-to-side wagging of the wrist that is really hard on the joints. With a trackpad, you are primarily using your fingers to glide and gesture. The benefit is that you can keep your wrist completely still and move your arm from the shoulder or elbow. Also, the lack of a physical click mechanism on modern haptic trackpads means you are not constantly slamming a switch down with your index finger. That repetitive clicking is a major cause of index finger strain. However, for precision work, people tend to tense up their fingers on a trackpad, which can cause its own set of issues. It is great for gestures and scrolling, but maybe not for 8 hours of pixel-perfect design work.
What about trackballs? They are like the vinyl records of the pointing device world. They have this dedicated, almost cult-like following. People who use them swear they are the pinnacle of ergonomics because the device itself never moves.
Trackballs are unique because they completely decouple the cursor movement from the arm movement. You are just using your thumb or your middle fingers to roll a ball. For people with shoulder or elbow issues, a trackball is a lifesaver because your arm stays totally stationary. There are two main types, thumb-operated, like the MX Ergo, and finger-operated, like the Kensington Slim Blade. The downside is that you are putting a lot of repetitive work on a single digit. We are seeing more cases of thumb joint issues in long-term thumb trackball users. It is a trade-off. You are saving your wrist and shoulder, but potentially taxing your thumb. If you go with a finger-operated trackball, you can distribute the load across multiple fingers, which is generally better.
It seems there is no perfect solution, just a series of different ways to distribute the stress. That leads me to something like the 3D Connection SpaceMouse. Daniel brought this up, and it is usually seen in engineering or computer-aided design offices. For a regular knowledge worker who is not building three-dimensional engine parts, is there a use case for something that's specialized?
The SpaceMouse is one of the most underrated tools for general productivity. For listeners who have not seen one, it is a heavy base with a puck on top that you can push, pull, twist, and tilt. It offers 6 degrees of freedom. In a three-dimensional environment, it lets you fly through space while your other hand handles the mouse for clicking. But in a two-dimensional world, like a massive spreadsheet, a long video editing timeline, or even a complex code base, you can use it to scroll and zoom with incredible fluidity. It allows for a two-handed workflow. Instead of your right hand doing everything, navigation, clicking, scrolling, dragging, your left hand handles the navigation on the SpaceMouse and your right hand handles the selection. Spreading the load across both limbs is fundamentally more ergonomic than overloading one side of your body.
That two-handed workflow makes a lot of sense. We usually have one hand glued to the mouse, and the other just hovering over the keyboard waiting for a shortcut. Bringing a second pointing device or a navigation controller into the mix seems like a smart way to balance the physical toll. But what about the left-handed community? I feel like lefties get the short end of the stick in almost every hardware category. If you want a high-end ergonomic mouse and you are left-handed, what are your options?
It is a bit grim, and it is something the industry needs to answer for. Most of the top-tier ergonomic research and development goes into right-handed models because that is where the volume is. Left-handed users are often told to use ambidextrous mice, but an ambidextrous mouse is, by definition, not ergonomic. To be truly ergonomic, a device needs to be contoured to the specific asymmetrical shape of a human hand. An ambidextrous mouse is a compromise that is equally mediocre for everyone. There are a few left-handed vertical mice out there, like the left-handed version of the Logitech Lift, which was a big win when it launched. But the selection is probably 10% of what is available for righties. Many lefties just end up training themselves to use a mouse with their right hand, which is its own kind of mental and physical strain.
That is a major missed opportunity for hardware companies. You have this highly motivated segment of the population looking for a solution, and almost no one is building for them. If someone is listening to this and they are convinced they need to upgrade, how should they go about it? Daniel mentioned an artificial intelligence tool, but if you are just starting out, what is the strategy? You cannot really go to a store and test these things for 8 hours to see if they hurt.
You have to commit to the 2-week rule. Your brain and your muscles have spent years, maybe decades, learning the micro movements of a traditional mouse. When you switch to a vertical mouse or a trackball, your precision is going to tank for the first few days. You will feel clumsy. You might even feel new muscles aching because you are using parts of your hand that have been dormant. Most people give up after 3 days because they feel less productive. You have to push through that adjustment valley. After about 14 days, the new muscle memory clicks in, and that is when you can judge if the pain is subsiding. Do not judge an ergonomic device by your first hour of use.
And what about the actual selection? Should people be looking at the sensor specs or the button types, or is it purely about the shape?
For knowledge work, sensor specs like dots per inch are mostly marketing fluff. Anything modern is precise enough for a spreadsheet. You should focus on 3 things: size, angle, and weight. If you have small hands, a giant vertical mouse like the MX Vertical might be worse for you because you will be stretching to reach the buttons. In that case, something like the Lift is better. If you move your mouse by lifting it frequently, weight matters. A heavy mouse will fatigue your wrist faster. And finally, look for a device that allows for a neutral wrist position. If you can find an app or a website that lets you print out a hand-size guide to overlay your hand on, do it. It is the best way to ensure the arch of the mouse matches your palm.
We should also mention the surface. We did an episode a while back, episode 587, about monitor ergonomics and the broader workstation setup. Your mouse ergonomics are partially dictated by how high your desk is. If your desk is too high, you're forced to angle your wrist up even with a vertical mouse. You need that 90-degree angle at your elbow to really get the benefits.
That's vital. No mouse can fix a desk that is at the wrong height. It is all part of a chain. If your shoulder is hiked up because the armrest is too high, that tension travels all the way down to your fingertips. Looking at the future of this space, we are starting to see some compelling developments in haptic feedback and even non-invasive neural interfaces. Imagine a pointing device that does not require you to move your hand at all, but just senses the intention of movement in your forearm muscles using electromyography, or EMG.
That would be the ultimate ergonomic win, removing the mechanical movement entirely. But until we are all wearing EMG armbands, it seems like the best we can do is be more intentional about the tools we are currently gripping. It is about treating your mouse like a piece of professional equipment, not just a plastic commodity that came in the box with your computer.
It's an investment in your health. I have seen so many brilliant developers and writers have their careers slowed down by repetitive strain injuries. It is much easier and cheaper to spend $100 on a good vertical mouse now than it is to deal with surgery or chronic pain 5 or 10 years down the line. And the tech is getting better. The fact that we have artificial intelligence tools now that can look at a photo of your hand and tell you exactly which model fits your grip pattern is incredible. It takes the guesswork out of it.
I wonder if custom molded mice will become accessible. With three-dimensional printing getting better and cheaper, it seems inevitable that you could just scan your hand with your phone and get a chassis that is literally a one-of-one fit for your specific anatomy.
There are some open source projects doing that right now. You can download files, tweak them based on your hand measurements, and print your own mouse shell, then move the internals from a donor mouse into it. It is a bit of a weekend project, but for people with unique hand shapes or specific injury requirements, it is a game changer. It goes back to that idea of the input stack being a deeply personal thing. We are moving away from the one-size-fits-all 1980s approach.
We spend more time touching our mice and keyboards than we do touching almost anything else in our lives, maybe besides our beds. It deserves that level of customization. Before we wrap up, I want to make sure we give some practical takeaways for someone who is currently feeling that dull ache in their wrist.
First, audit your grip. Are you tensing up? Are you using a tiny mouse for a large hand? Second, try a vertical mouse, but give it the full 2 weeks. Do not judge it on day 1. Third, consider a two-handed approach. If you are doing a lot of navigation, maybe a SpaceMouse or a trackpad on your non-dominant side can take 40% of the load off your clicking hand. And finally, check your desk height. Your mouse can only do so much if your arm is at a weird angle.
That's practical advice. It is about building a system that works with your biology instead of against it. We should probably mention that we have explored related topics in the past. If you are interested in how the keyboard fits into this, check out episode 859, where we talked about alternative keyboard layouts like Dvorak and Kolomak. It is the same philosophy of questioning the legacy hardware we have been handed.
And if you want to see how the mouse fits into the overall command center, episode 587 on monitor ergonomics is a great companion to this discussion. It is all about that holistic workstation health.
Well, I think we have covered the bases on the shark fin mice and the 6 degree of freedom pucks. It is a compelling niche that more people should pay attention to before the pain starts. Thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes.
And a big thanks to Modal for providing the GPU credits that power the artificial intelligence research and generation for this show. They make it possible for us to dive deep into these technical topics every week.
This has been My Weird Prompts. If you found this episode helpful, consider leaving us a review on your podcast app. It really helps us get the word out to other knowledge workers who might be nursing a sore wrist.
You can find all our past episodes and the full archive at myweirdprompts.com.
Until next time, stay curious and watch your grip.
Goodbye, everyone.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth.